Hello there, this is Ms. Martinez, and in this video we are looking at properties of limits. So let's get started. You as a student will be able to use properties of limits to evaluate graphically, numerically, and algebraically. That's what we are striving to do through the examples in this video. So, the principal limit theorem, sorry about that, states the following. Let B and C be real numbers, and N is going to be some number greater than or equal to 0. And we're going to let F and G be functions with limits at C such that the limit of F, the function f as x approaches c, is a number L, and the limit of your function g as x approaches c is going to equal m. That's going to be kind of the setup that leads into all of the rest of the theorem, which is going to include the different properties that are going to help us to find limits very quickly. So let's get started with the constant rule. If you're looking at the limit of a constant value as x is approaching c, it's going to be k. It's going to be that constant value. Graphically, let me explain. You have k being a constant value, so the graph would be a horizontal line. The point C on the line is right there. And from the right and left, clearly we are approaching the k value. So I think that this graph helps to explain the why behind the rule. Next, identity rule. If you're taking the limit of x as x approaches c, it's going to be c. The reason being can also be seen graphically. X is going to be just that very basic linear equation that's just constantly increasing there. So if you're looking at it, the point C on the graph, well, there it is. And if you plug in C, well, the height is also C. On this graph, you can see C is 2 places away. Well, then the height would also be 2 places up from the origin. So there you go. I hope that that helps to explain why that makes sense. Coefficient rule. Okay, you have b times the function f. And what's the limit of that as it's approaching c? Well, it would just be the limit of b times the limit of the function as those are approaching c. And then you have to look back to our previous ideas. Okay, the limit of a constant is just the constant, and the limit of your function we already defined as L, so it would be b times L. This is going to be used a lot. Okay, so that's the coefficient rule. What if you have 2 functions that you're adding together and you're trying to find the limit of them? You just take the limit of each of them separately and add it together. So that would be L plus M. Difference rule, same principle applies. You're just going to be subtracting those limits. So you take the limit of f and subtract from it the limit of g, that's L minus M. That's the difference rule. Now we talk about the product. Okay, if you have 2 functions that are being multiplied and you're wanting to take the limit of them, just take the limits separately and multiply the result together. In this case, that would be LM, which are my initials. That's awesome. I just realized that, like, in this moment. Okay, back to business. That was the product rule. Now the quotient rule. We're looking at the limit of the quotient of those two functions. And yes, you're probably thinking, well, is it like everything else? And I'm going to answer, well, yes, it is. You're just going to take the limit of the function of f and divide it by the limit of the function of g, which would be L over M. That was the quotient. Now, I misnamed this. This is the product power rule. Oh, I'm a terrible person. Okay, this is the power rule. Power rule because our function has been raised to the power of n, and we're supposed to be taking the limit of this. To do so, you would just take the limit of the function and raise it to that n power, which would be L to the n. All right.